Okay, this is 1.5 and part of 1.3. Now, today's topic, when you do your assignment, I want you to do this page section first on page 191, then go back to 163, okay? I think it'll just be easier when you do the slightly easier questions first and then do the little bit harder ones in that order. Okay, this is a very pre-calculus topic. A lot of the things we're going to talk about today will get you ready for a chunk of calculus that's an important element of calculus. All right, you're going to be asked a lot to find the average rate of change. What does that mean? Well, basically, that's just finding the slope. So what is that? Why do we change the name? Well, the reason why we change the name from slope to average rate of change is that we almost always use slope when we're talking about the difference between 2 points on a line. But you can also ask for the slope between any 2 points on a curve. You can see here's a point on a curve. This is my curve right here. Okay, and here's another point on that curve. So if we take the, the average between those 2 points and find the slope, I'll just stop it. I just started, I can start again. Oh no! Okay, so, sorry, I had a little interruption there. So, like I was saying, the slope is between 2 points on a curve, but we can still find the slope. They just changed the name to average rate of change. So you'll notice that the formula is the same. The formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the change in y over the change in x. But we just changed the name ever so slightly. F of x sub 2 means that we're going to take an x sub 2 value, like 4, and substitute it into the function, and the answer is going to be y sub 2. So it's kind of saying the same thing. It's kind of a before and after of the same value. But basically, this is still just y sub 2. It's just a different way to write it. And this is still just y sub 1. It's just a different way to write it. So as you can see, if I use this as x sub 1 and x sub 2 and y sub 2, because it's farther to the right, the first one would be over here. This is x sub 1 and y sub 1. I can use those values and just take the slope between those 2 points. That's what average rate of change is, and solve and get an answer. Now, here we can do this. If we don't have the y values, we have to do a little bit more work in advance. So for example, if they give me the 2 x values but they don't give me the y values, what I can do is I can find them. I can find the y value that goes with the x sub 2, which is 3, by substituting 3 into the original function. So f of 3 equals 3 squared, which is 9. That is y sub 2. Or I can find y sub 1 by substituting in x sub 1 into the original function. So that would be 1. 1 squared is 1. So y sub 1 is 1. So that goes there in my slope formula. And then I just solve to get my answer, which is 4. Same kind of thing. Example number 2, we're going to pick 2 different points on this curve. So if we have the position where x is negative 4 and the position where x is negative 2, we can find our slope. Again, this is the bottom of the slope, x sub 2 minus x sub 1. So that would be negative 2 minus negative 4. And so now we need a y sub 2 and a y sub 1 to complete our formula, right? So y sub 2, all we need to do is substitute in x sub 2 into the formula. So x sub 2 is negative 2. Substituting that into our formula gives us negative 2 squared, which is 4. That goes there for y sub 2. And then to find our y sub 1, we would take our x sub 1, which is negative 4, substitute it into the formula, and we get negative 4 squared, which is 16. So that's y sub 1, excuse me. So finding your y sub 1s and y sub 2s, here's your y sub 1 and here's your y sub 2, are not so hard because you already have your formula and your x's to substitute in. So then you subtract and simplify, and you get negative 6. Now, another way to ask the question about slope is to ask about average velocity. Again, average velocity is just a fancy way to ask for the slope. And again, you can see the formula is pretty much the same. This is still y sub 2, this is still y sub 1, this is still x sub 2, and this is still x sub 1. It's just the lettering has changed. They've used different letters, so instead of y and x, they've used d and t, but it's pretty much the same thing. So, over here, here's my function, d of t equals 4t squared, and they give me t sub 1 and t sub 2. Remember, that's the bottom of my slope formula, t sub 2 minus t sub 1, so 2 minus 1. Now the y values on top, the y sub 2 and y sub 1, I have to calculate those. So those, I will have to substitute my x's into the formula, or in this case my t's into the formula to find them. So you can see that I've done that right here. To find d sub, or y sub 1 basically, or sorry, y sub 2, which is the same as this right here, I substituted my t sub 2 into the formula, which is again here. So it would be 2 squared times 4. 4 times 4 is 16. So that was my y sub 2. And then y sub 1 would be the same as this. So substituting t sub 1 into the formula would give me 4 times 1 squared, or 4 times 1, which is 4. That's just like my y sub 1. It is my y sub 1. It goes there in the formula for slope. So again, just as with number 1 and number 2, they gave me the x values. In this case, they're called t's. And we need to find the y values. And we did that and substituted in and solve. Now, the difference quotient. The difference quotient is basically a formula to find a slope for a specific function. You'll notice that h down here is defined as x sub 2 minus x sub 1. Isn't that what slope is on the bottom of the formula for slope? Yeah. This is still y sub 2, and this is still y sub 1. The only difference is they gave it different names. Now, what we use this for, again, is to create a formula. Usually, we find numerical answers. Today, we're actually going to create a formula. The difference quotient is kind of like a custom-made suit. If you have a difference quotient formula, you can use it to find the slope, but that slope is only applying to one formula, or one function. So let's say if I have a function g of x equals x squared plus 3, I can find the difference quotient for this, and I can use that to find the slope, but that's only going to work on this graph, x squared plus 3. All right, I'm going to switch over to video number 2.